They're marketed as batteries, but we call these things cells. And there are two types: primary, which can't be recharged, and secondary, which can. And so I decided to make a video about an experiment charging and discharging a secondary cell. And to do that, I've set up the charger on my desk, and I'm using this tripod, and that's going to help me to record an image of the charger every 2 minutes for as long as it takes to discharge and charge 4 separate cells. Here is the apparatus that I'm going to use. I've got this intelligent battery charger, which, as you'll see, is perhaps not that intelligent, but it does do a good job of charging and discharging cells. And I've set the mode to charge, and each of these cells is busy charging up, and the voltage will get up to about 1.46 to 1.5 volts. And then it will report that they're full. What I'm going to do then is to change the mode. So I'll do that on this first one so you can see. I'll change the mode to discharge, and the current will be 250 milliamps. So that should discharge this 650 milliamp hour cell in just under 3 hours. Now this is where the smart charger isn't so smart, in my opinion, because you'd think that if it's discharging, that cell's going to stay discharged at the end, and I'll have 4 discharged cells, and I can then start the process of taking photographs using this intervalometer 1 every 2 minutes. But the smart charger doesn't do that. As soon as the cell is discharged, it immediately charges it up again. So after 2 nights of wrestling with that and not getting it correct, I decided to just go with it. And so I'm going to fully charge these cells and then discharge them from full and take a photograph using the intervalometer every 2 minutes. So the way it's set, the interval is 1 minute and 59 seconds, and the duration of each photograph is 1 second. And so it will send, once I press start, a signal through this cable up to the camera, which is at the moment busy recording this video, but I'll change that so that it's taking still images. And it will take 400 pictures throughout the night or until I tell it to stop. And that should record the change in the voltage of these cells. Now, there are different displays that we can have. So if we look at the charging current is double the discharge current, and apparently that's good for the cells. So I've set them all to the same current, but that doubling factor takes effect. If I change this back to charging, you'll see that it goes to the 500 milliamp current. You can get a voltage display, and that's what I'm going to be recording. You can also see the total charge that's gone in or out of the cell in milliamp hours, and also the time that it's been charging or discharging. But I can't automatically cycle through this display, so for the purpose of the demonstration, I'm just going to have the voltage values, and you're going to see 400 of these images as the cell goes through its cycle. What you're going to see is that when they discharge, they'll discharge rapidly from the high value, and they'll get down to some minimum of about 0.9 volts. And that's when the charger will automatically start charging them again, and they'll charge with twice the current, so it will be very quick. You'll see the numbers changing rapidly. But not all cells are going to behave the same way. So cell number 3, either the cell itself or this slot in the charger has a bit of a problem, and you'll see that in the time-lapse video. So that's the explanation. I'm going to leave it to charge so that they're all full, and then you'll be able to see the whole time-lapse video. Here's the result. The cells start with a high voltage which decreases as they discharge and then increases rapidly as they recharge, except for cell number 3. As the time goes by, that cell just stays on 1.11 volts, and there's clearly something wrong with it. Let's look at the display, and you can see the voltages of the other 3 cells are nice and high. And the claim is 3.8 amp hours. That's 3,800 milliamp hours. The cell's been charging for 15 and a quarter hours, at 250 milliamps. So clearly something is wrong with that cell. You can compare the results with the others. So I think the charge is not that accurate. And looking at those final voltages, something's clearly wrong with that cell. But I hope that gives you enough data. So you could now go and plot these results on a graph against time. Remember, each photograph took exactly 2 minutes. And you could see the full discharge and charging curves for 3 of the cells, but not for the third cell, which is anomalous. Something's wrong with either the cell or the third slot in the charger.